taken the look of the uh, rules of Boolean algebra. And with that, we have also have taken the look of the De Morgan's law. And with the De Morgan's law, we are actually able to reduce the expression, and then we are able to actually draw the logical circuit diagram, right? So up till now we have seen these things. So now what we can go ahead with that, there are, let's suppose if we say we have two variables, right? So if we have two variables, let's suppose we have two variables, x and y. Now x and y, they can have a total of four combinations, and the four combinations will be 0 0, 0 1, 1 0, and 1 1, right? Now if we want to represent this in the AND gate terms, so they will be represented as, you can say the terms, they will be represented as x complement y complement, similarly x complement y, similarly x y complement, and xy. Now if you see, what we are trying to get from here is basically we say that the AND gate terms, when they are being ANDed, the two variables, when they are being ANDed, so they produce a logical high output, right? So when they produce a logical high output, so this means that always when we are ANDing the two variables, we get a high output. High output means if we are ANDing with the values, we are going to have the output equal to 1, right? Now this kind of terms which are producing a high output, they are normally called the min terms. Min terms, right? Now min terms, they, for two variables we can have, like min term is being represented with a small m and with the subscript or here as 0. Now 0 is basically representing the decimal equivalent of that term. Similarly, this 0 1, as 0 1 represents in decimal equal to 1, so when we are representing the main term, so it will be small m with a 1 over here. Similarly, 1 0, 1 0 is having a main term equal to x y complement, and so we say it is m of 2. Similarly, 1 1, they are representing the decimal equivalent to 3, and therefore we will write min term m of 3, right? Now if, let's suppose if I have, instead of two variables I have three variables, right? So if I have three variables, and the three variables are, like we say, x, y, and z, right? Now x, y, and z, so this means they can have total of 8 combinations, which is 0 0 0, then 0 0 1, then 0 1 0, then 0 1 1, then 1 0 0, then we can have 1 0 1, then we can have 1 1 0, and then we can have 1 1 1, right? Are you with me? Now the terms which will be producing the with the AND gate, so this means we have an AND gate which is which is having three inputs, right? So AND gate which is having three inputs. So the terms will be x complement, y complement, z complement. Similarly, we have x complement, y complement, and z. Similarly, we have x complement, y, and z complement. Similarly, we have x complement, y, and z. Similarly, we have x, y complement, and z complement. Then we have x, y complement, and z. And then we have x, y, and z complement. And then we have x, y, and z. Now, their respective minterms will be represented as minterms. They will be represented as m of 0. M of 0 means it is the minterm which is having 0 as a subscript, means it is basically representing the decimal equivalent of the combination of all of the variables. So the all of the variables x is 0, y is 0, and z is 0. So 0, 0, 0, which is equivalent to decimal 0. So therefore what we say, it is m of 0. Similarly 0, 0, 1, so it will be represented as m of 1. Similarly 0, 1, 0, it will be represented as m of 2. Similarly 0, 1, 1, it will be represented as m of 3. Sorry, I have a bad throat. So then it is 1, 0, 0, it is m of 4. Then it is 1, 0, 1, that is m of 5. Then it 1, 1, 0, it is m of 6. And similarly 1, 1, 1, which is m of 7, right? So this is basically the minterms, and if we just go along with it and we say, now these minterms, they are also being called as standard product. It is also called as standard product. Or we can say these are basically the minterms, right? Now if you see, if I have something function, if I say I have an expression, or I say a function, let's suppose the function is f is equal to, I say x complement y complement z plus x y complement z plus x y and z. Now if we want to see that, if I want to represent this function in terms of minterm, so what I can do, I can go back to the table which I have made, and if you see, I can compare it from the terms which are available in the function. So now the first term is x complement, y complement, and z. So what does this mean? This means x complement, so x is 0, y complement, y is 0, and then z is 1, right? So this means it is 0, 0, 1. Now if I go back and see where is 0, 0, 1, so now you can see that 0, 0, 1 is here, right? Now this is 0, 0, 1, and 0, 0, 1 is being represented as m of 1 over here, right? So what I can do, I can replace x complement, y complement, and z as, I can say, I can write it is m of 1, right? Then I have x, y complement, and z, right? Now x, y complement, and z, x, y complement, and z. will be represented as, this means x is 1, y complement means y is 0, and z is 1. So it is 1, 0, 1. Now 1, 0, 1, if I see, it is here, right? It is 1, 0, 1, and 1, 0, 1 is being represented as m of 5, right? So this means I can replace this x, y complement and z with m of 5, and then I have x, y, and z. X, y, and z means x is 1, y is 1, and z is 1. So what I can do, I can check it out, and this is 1, 1, and 1. So this means it is m of 7, right? So what I can do, I can just replace, and instead of x, y, and z, I can write m of 7 over here. So this means this function, which was previously x complement, y complement, and z, plus x, y complement, and z, and plus x, y, and z. This means it can be replaced with m of 1, m of 5, and m of 7, right? Similarly, uh, we have another term which is called max terms, right? Now, max term is basically the complement of the min terms, right? And the complement of these terms means how we can represent those terms, that by taking the complement of x complement, y complement, z complement, whole complement, right? So this means if the min terms, they are presenting high output, so the max terms, they will be presenting the low outputs, right? So the max terms, they will be, so we have the same thing, x, y, and z. So x, y, and z, when it is 0, 0, 0, so the max term will be, how we can represent the max terms. So let's see how we can represent the max terms. Now I say, let's suppose the max terms. So if I take the complement of m of 0, which is equal to x complement, y complement, and z complement using the De Morgan's law. So how I can use it? I can actually take the values which is as it is in this specific case. So what is this? So in the min term, it was x complement, y complement, and z complement, and the min terms, they are representing the output equal to 1. So the max terms, they, as they are the complement of the min term, so they will be representing the output equal to 0. And this means, and the min terms, they are ended with one another, but the max term, they will be odd with one another, right? So in that specific case, I can write x plus y plus z. Now, if you see, what is the value of x, y, and z? X is 0, y is 0, and z is 0. So when I am going to add x 0, y 0, and z 0, so the max term, so the max term will be represented as M capital with a subscript 0, right? So again, this is representing that, it is representing the complement of the min term, and which is also representing the decimal 0, right? Similarly, what we have, the next number is 0, 0, 1, right? So what we want to do, we want to, when we add the three variables, they should produce the output equal to 0, right? So this means we have x is 0, y is 0, and z is 1, right? So what we need to do, we need to have x is 0, y is 0, and z is 1. So what we need to do, we need to take the complement of z. And when we take the complement of z, so this means the term which is the max term, it will become equal to 0, right? So this means this will represent m of 1, right? Similarly, I have 0 1 0. 0 1 0 means I can have the max term which is equal to x plus y, and this is 0 1 0, right? So x plus y complement plus z, right? Similarly, the next one is 0 1 1, right? 0 1 1. So again, I want to have the output that should be equal to 0. So 0, x is 0, y is 1, so this means I will take the complement of 1, and z is 1, so this means I will take the complement of z as well. Then I have the next one is 1 0 0. 1 0 0, this means x is 1. So when x is 1, so this means I need to take the complement of x plus y is 0 and z is 0. Then the next one is 1 0 1. 1 0 1 means x is 1, right? When x is 1, so I need to take the complement of x plus y is 0. So y is going to be taken as it is, and z is 1, so I need to take the complement of z. Then I have the value is 110. So 110 means I need to write down 110. This means x is complemented plus y is complemented and plus z is not going to be complemented. And then the last one, which is 111. So for the max term, it will become x complement plus y complement plus z complement, right? So now what we can do, we can write down the max terms in front of their respective values. So this means x plus y plus z is m of 0, then x plus y plus z complement is m of 1, then x plus y complement plus z is equal to m of 2. Then x plus y complement plus z is m of 3. Then x complement plus y plus z is m of 4. Plus then we have x complement plus y plus z complement is m of 5. Then x complement y complement plus z is m of 6. And then x complement plus y complement plus z complement is m of 7, right? So these are basically the max terms, right? Now if we have the max terms, so the max terms, they are also called the standard sum, right? So the max terms, they are also called the standard sum, right? So the min terms, they are called the standard product, and the max term, they are called the standard sums, right? Because if you see in the max terms, all the terms, they x plus y plus z, right? So they are being odd with one another, which is in mathematics it is called sum. And if you see in the min terms, they are actually having the AND gate in between them. And AND gate in between them is basically in mathematics, it is called, or in algebra, it is called the product form, right? So therefore, the term is being called as the standard product. for the min terms and standard sum for the max term, right? Now let's suppose if I have another function, let's suppose I have a function. The function is represented as what I would say that let's suppose I have a function something. So I have x, y, and z. So this means I have 0, 0, 0, I have 0, 0, 1, then I have 0, 1, 0, then I have 0, 1, 1, then I have 1, 0, 0, then I have 1, 0, 1, and then I have 1, 1, 0, and then I have 1, 1, 1, right? So they are actually, I have three variables. So when I have three variables, so this means I can have a total of 8 combinations, right? Now I have a function. Let's suppose I have a function f1, right? And the f1 is having a value 0, 1, 0, 0, 1, 0, 0, 1, right? 0, 1, 0, 0, 1, 0, 0, 1, right? Function f1. Now what does this mean? This means this function f1 have a min term m1, then I have a min term m4, and then I have a min term m of 7, right? This is a function. And m1 is basically equal to, what is m1 equal to? From our previous knowledge, we can write it down: x complement, y complement, and z. Then m4 is equal to 1, 0, 0. So this means this is x, y complement, and z complement. And then m of 7, which is equal to x, y, and z, right? So what I can do, I can just streamline this thing. Assalamu alaikum, sir. Sir, class akhlam. Singh sir. Ha, khair shi. Sir, khabar ho? Ha, sahi hai. Sahi shi. Okay. Okay, Ji. So what we have f1. So what I can write, f1 is equal to m of 1 plus m of 4 plus m of 7, right? So similarly, now if I take the complement of this function, right? So this means if I want to take the complement of this function, what is going to be the complement of this function? Now the complement of this function means it should be all zeros, right? So from this, F1 where we have zeros, right? So the zeros, they are actually representing the max term, which I have told you. So the ones, they will be representing the min terms, and the zeros of this function, they will be representing the max terms. So this means our zeros over here, 0, 0, 0. So this means it will be represented as capital M of 0, right? Or let me change the color. So this means it is M of 0, right? Then this is M of 2, then this is M of 3, then this is M of 5, and then this is M of 6, right? So this means these are basically the complement of this function, right? So if I go back and I say what is the complement of this function, it will be represented as, or what I can say, if I take the values over here, so f1 complement will be simply, how I can do it, if I just take the complement of this, and the complement of this over here is, I can take 0, which is, so if I take 0 over here, which is representing x complement, y complement, and 0, right? So this means it will be x complement, y complement, and z complement, right? Then I have, where I have 0, it is 0, 1, 0, right? So it will be, which is m of 2. So it is 0, 1, 0, right? So it will be x complement, y complement, y, and z complement, right? Then where I have 0, I have 0 at 3, which is 0, 1, 1. So 0, 1, 1 will be represented as x complement, y, and z, right? Then where I have another 0, I have a 0 at 5, which is x, y is complemented, and then I have z, right? So this means it will be plus x, y complement, and z. And then I have, where I have another 0, I have 0 at 6, which is 1, 1, 0. So 1, 1, 0 will be represented as, 1, 1, 0 will be represented as, right, it will be represented as 1, 1, 0 x, y, and z complement, right? So now this is our the function which we have obtained from f1 complement. Now if I again take the complement of the complemented function, what I'm going to get from f1 complement if I take another complement, right? So this means I have now this whole function over here, I will be using the De Morgan's law, right? So by using the De Morgan law, the first term is x complement, y complement, and z complement, right? And if you remember the De Morgan's law, which we have seen in the last lecture, if I have, let's suppose, x complement, y complement, and if I take the complement of this, so it will become x plus y, right? Or similarly, if I have x complement y, and if I take the complement of this, this will become x plus y complement, right? So the situation over here, what we have is I have x complement, y complement, and z complement, right? So if I take the complement of whole of this, so what will happen? So this will become what I can say x complement, y complement, z complement, right? Now, so I put it in the bracket, and then I say I have x complement, y, and z complement, right? And then I have plus x complement, y, and z, and then I have plus, okay, then I have plus x, y complement and z plus x, y complement and z and plus x, y and z complement, and I say that it is all of them is complemented, right? Right. Now, when everything is being complemented, so this means f1 complement complement, so this means it will become now f1, right? Now whole of this complemented means the thing which is in the bracket, it is all going to be complemented, and whatever the OR function which we have due to the De Morgan's law, this will become the AND, right? And within the bracket which are being ANDed with one another, they will be ORed with one another, right? And whatever the function is there, it is going to, whatever the variable is there, it is going to be complemented. So using the De Morgan's law, the first one, if you see x1, x complement, y complement, and z complement, and then this is whole complement, right? Then there is plus, so plus with a bar on top of it, this will become a dot over here, right? Similarly, the rest of the things, they will also become the dot over here. It is x complement, y, and z with with a complement. Again, this is OR over here, so this will become the and then we have x complement, y, and z. So this is complemented, right? And then we have the OR over here, so it is going to be a dot with the x, y complement, z. This is complemented, and then there is an OR, so this will be converted into and then it will be x, y, and z, and this is complemented, right? Now the function over here, if you see x complement, y complement, z complement with complement on top of it, so this will become x whatever, because previously x and y, they were ANDed, so they will become OR, so this means x plus y plus z with a bracket. Then there is an AND gate, and then I have x complement plus x complement y and z complement. So this will be converted into x plus y complement plus z, right? And then I have x complement y and z, so it will be converted into x plus y complement plus z complement, right? And similarly, we have then again the and then I have x, y complement and z whole complement. This will be converted into x complement plus y plus z complement, and then the next one is x, y and z complement. It will be converted into x complement plus y complement plus z over here, right? Now what you can see, that these terms which are within the bracket, they are basically the max terms, and we can compare them with the terms which we have written uh, in the table previously. So what is x plus y plus z? If we go back and we see over here, what is x plus y plus z? This is basically, from here we can see, this is x plus y plus z is basically m of 0, right? So what we can do, we can just write over here function we can just write over here function f1. This is m of 0 dot, then x plus y complement plus z. This is function basically, and this is basically the max term m of 2. Then if we just compare it, which is x, y complement and z complement, which is basically m of 3, then we have this x complement, y and z complement, which is basically m of 5, and then we have x complement, y complement and z complement, which is basically m of 6, right? So if you see what we have actually taken a look over here, that same function can either be represented as the in the terms of min terms, or it can be represented in the max terms. Now whenever it is being represented, the same function, when it is being represented in the min terms, if you see over here, so this is basically called the the sum of min terms, or it is also called the sum of product form, because the min terms, they are in the product form, so it is also called sum of product form, which is called SOP, sum of product form, right? And whenever the same term, the same function is being represented in the max terms, it is basically called the product of sum form, right? So it is called the product of sum form. In the max term, it is called the POS, product of sum form, which is normally called as product of sum form, right? POS. And the other one is called SOP. SOP is basically, if you see, it is called the sum of product form, right? So the SOP is being developed from the minterms. SOP is being developed from the minterms, and the product of sum form is being developed from the max terms, right? So the max terms, they are always in the form of they are being one max term is being ANDed with another max term, right? So this means that it is because the max term is made up of summing of the input variables. So, and in combined form, they are being in a product to one another, right? So therefore it is called product of sum form. And the other one, the minterms, they are being developed with the product form, right? Because the variables x, y, and z, they are ANDed with one another, and when they are ANDed with one another, so then the minterms, they are being odd with another minterm, right? So therefore it is called sum of product form, and the other is product of sum form, right? So we have either the product form or we have the sum form, right? And these are basically the two standard forms which we can have from the minterms and from the max terms, right? Now with this, they are basically used when when we are actually working with the logical gates. So in the product of sum form or the sum of product form, so in sum of product form, first we are using the AND gates, and then we are using the OR gates, right? So let's take the example, whatever we have over here, the M1, M4, and M7, right? So SOP form, if we want to develop the logical circuit diagram from this M1, M4, and M7, right? So what we have, so we have the three inputs X, Y, and Z, right? So the first one is X1, and X1 is being represented, M1 is being represented as 0, 0, 1, right? So if we have X and what we do, we take the NOT gate. So this means now it is X complement. So M1 is basically 0, 0, 1, right? We take the NOT gate and we take this, right? And we put this to an AND gate, right? This one is actually providing us M of 1, right? Then what we have M of 4. M of 4 is basically 1, 0, 0, right? So this means we are providing X directly to it. Then we have X is 1, Y is 0, and Z is 0, right? So Y complement and Z is also complemented, right? So this means this is M of 4, right? And then we have M of 7, right? So X, Y, and Z all are being given. All are being given to an AND gate. And this is developing M of 7, right? So this means in the first stage we have the AND gates, and then after this stage we provide the output of the AND gate to the OR gate, right? right? So this means we have now the function f1 over here, which is equal to m1 plus m4 plus m of 7, right? And similarly, if you want to see it in the form of the product of sum form, so in the product of sum form, first we will using the OR gates. So the OR gates, they will be providing us the max terms, and once we have all the max terms from the OR gates, then we provide the output of the OR gates to the AND gate, right? So in that specific case, what we have the first, we will have the OR gates. OR gates, they will be providing, let's suppose m of 0, then another OR gate, it will be providing m of 2, then another OR gate, it will be providing m of 3, then another OR gate, it will be providing m of 5, and then another OR gate, it will be providing us m of 6, right? Now all these outputs from different OR gates, they will be given it to the AND gate, right? And the output of the AND gate will be providing the function f of, right? So one is basically the sum of product form, right? This one is basically the logical diagram for SOP, and this one is basically the logical diagram for, and this is the logical diagram for product of sum, right? Okay, so if you see, we have now covered the sum of product form and the product of sum form. Now with this, what we can do, so we can have different levels, right? So let me give you an assignment, and in the assignment you have to uh, do, and you have to actually play around with the few things. So before going into this, so what we can do, if we have any expression, something like an expression which is being represented as function, and if it is said function x comma y comma z, right? And it is being represented as summation 137. What does this mean? This means it is the function for sum of product, right? So this means you have the sum of product. So this means the one which is inside the bracket, they will be representing the min terms, right? And the summation over here, this means that whatever the min terms, whatever the terms we have, they will be summed with one another. So this means it will be represented as x, y, and z, with 1 means it is m of m of 1 is 1, plus what I have, plus m of 3, and plus m of 7, right? Now, what is m of 1? M of 1 means it is representing the decimal 1. So it will be 0, 0, 1, or if you have, you can just go back to the table which we have created previously, and 0 0 1, and 0 0 1 means it is x complement, y complement, and z. Then m of 3 is means it is representing decimal 3, which is 0 1 1, and 0 1 1 means I have x complement, y, and z. And then m of 7 means it is representing decimal 7, which is 111, so it will be represented as x, y, and z, right? So in this what we can actually have, we can actually represent the function something like that. Similarly, I have another function which will be represented as function, again x, y, and z, right? X, y, and z, when it is written pi, and if it is written 0 comma 3 comma 6 comma 7. Now this means this is representing product of some form, right? And product of some form means it is representing, so the it will be representing the max terms, and max terms means the function is actually going for the zeros what are in the function, and then it is basically being going to be written in the product of some form. Product of some form means m of 0, then dot m of 3, then dot m of 6, then dot m of 7, right? And if you go back to the table, you can actually take a look that which we have done previously. We have m of 1, m of 0, m of 1, m of 2, m of 3, and what we have written, which is in the standard sum form, and then the main term, which is being written in the standard prod form, right? So this is something which you should be knowing, that how you can actually go along with the sum of product form or product of sum form, right? And with that, how you can actually draw the logical diagram for the SOP, and how you can draw the logical diagram for POS, and how you will be able to convert the product of sum form into sum of product form, or sum of product form into product of sum form, right? So in the book which we have, you have the you have let me just show you. Okay, ji, in the book there is an example, example 2.4, the books which I have already shared with you. So just go with the example. The example 2.4, the expression function is f is equal to a plus b complement c is in a sum of min terms. The function has three variables, as you can see, a, b, c. The first term a is missing with two variables, and therefore you can actually increase with using the previous knowledge, which is a into b plus b complement. So there, you know, when you add b plus b complement, which is equal to 1, so this means nothing is going to change. And similarly, you can add c plus c complement, and this means you can actually enhance the number of terms. And once you have done this, so you can actually uh, increase the number of terms. And once you have done this, you can actually go with the rest of things. And once you do that, and then you can actually come up with the actual number of main terms which are there in the function. So let's go through the same example, and we see that how we can do that. And now let's suppose we have a function a plus, in the book it is being given, which is a plus b complement c. A plus b complement c, right? Now we have to convert this function into the required number of midterms. So as you know, a, the first term, if we add b plus b complement with this, we are going to have ab plus ab complement, right? Now again ab and ab complement, they are missing the third variable. So what we can do, ab, we can add c plus c complement with this, and similarly ab complement, we can add c plus c complement with this. So this is abc plus abc complement plus ab complement c plus ab complement and c complement. Now this term, which is b complement c, we can add a plus a complement with that. With that, what we can do, a plus a complement into b complement c. So with this, we are going to get a b complement c plus a complement b complement and c, right? Now if you see, we have now a b complement c and a complement b complement c that will be added in this. So what we can say, we can add this over here, plus a b complement c plus a complement b complement and c, right? So if you see what we have, a b c in the function, we have function is a b c, then we have a b c complement, a b c complement, then we have, if you see, we have a b complement c over here, as well as we have a b complement c over here. So this means, if you remember, x plus x, which is again x, right? So this means we only have a b complement and c, plus then we have a b complement c complement, a b complement c complement, and plus we have a complement b complement and c, right? Now from here, what we can do, we can actually look into the function that it has basically the 5 terms, and we can actually go and see which of these terms are representing the which specific min terms. So ABC is actually representing m of 7, right? Then A, B, and C complement. This is 1, 1, and 0. 1, 1, 0 is basically representing m of 6, plus 1, 0, 1, right? So 1, 0, 1, this is representing m of 5. Then A, B complement C, 1, 0, 0. This means it is representing m of 4. And plus 1, A complement, B complement, and C, which is representing 0, 0, 1. 0, 0, 1 means it is m of 1, right? So this means the function can be written as A, comma B, comma C, which is equal to summation. Then we can start from the lowest one, which is 1, comma 4, comma 5, comma 6, and comma 7, right? So this is how it is being done. Okay, so if you see, this was the thing, and we obtain this from the. Similarly, you can go ahead with the examples which are given in the book, and you can just go ahead with thing. Okay, so the example 2.5 which is given in the book, so it is what you have to do, you have to convert into the max terms, right, or convert the function into odd terms using the distributive law. So you can just go ahead with this example, and once you have done this, so you will be actually this. And similarly, conversion between canonical forms, so this means you can actually transform the product of sum into sum of product, or sum of product into product of sum, right? So in the book you have the, at the end of the this chapter, in the end of the chapter in the book, you have the you can see in the book you have 2.13 and 2.14, right? So just go through this. So convert the following to the other canonical form. So you have function xyz, and you can have the function abcd. Okay, abcd means you can actually have, when you have 4 variables, so this means you will be having a total of 15 sorry, total of 0 to 15 decimal numbers, and 0 to 15 decimal numbers mean you can have a total of 16 terms, right? And once you have 16 terms, so similarly you can have the min terms from m of 0 to m of 15. Similarly, you have max term from m of 0, capital M of 0 to capital M of 15, right? So the assignment for the this week is basically in the book you have the at the end of the book you have question 2.13 and question 2.14, right? So these are basically the assignment, and you have to just work along with this, and I will post it, and you will submit it before the start of the next class. Okay, thanks a lot for listening to this, and if you have any question you can ask me later on. Thank you.